Welcome all. On this channel, I like to discuss geospatial analysis and GIS related concepts. In this video, I will continue discussing cursors, this time focusing on the insert cursor. As per the Esri documentation, the insert cursor establishes a right cursor on a feature class or table. Insert cursor can be used to add new rows. Link to the documentation will be in the description of this video. So what does this function enable? With an insert cursor, you can create new features based on calculated geometry or attributes, or refer to existing features and create new features based on applied analysis. In the displayed map is a time loop of South Australia crime data. I produced this from the South Australia Government Data Directory, combining that with the Australian Bureau of Statistics postcode boundary data. I referenced this in the previous video. Links for these datasets will be available in the description. What you're viewing in the background is the weekly total count of offences recorded for that postcode area. This is for the financial year 2022 to 2023. I achieved that output by combining the CSV on the right with the boundary feature class data on the left. What I've created is a multi-dimensional feature class. That's a feature class that covers both time and space. So what this means is that polygons will overlap but will refer to different time periods. So querying on this polygon area, we've got multiple polygons overlapping each other, but as you see, the reported date is changing. And the information about the reported offences and total count is captured there as well. To my knowledge, this is not easily repeated using the join and relate using ArcGIS Pro. So to demonstrate the use of the insert cursor, I'll use the crime data that I've displayed here. And what we'll use the insert cursor for is selecting all of the categories out of the data that coincide with this list here. These are all the major serious crimes that have been recorded. While this task could be completed manually, you could copy and paste a list like this into a SQL query and extract the data that way. Using a Python script like this, you could conduct multiple query sets over a large amount of input data. That would enable the simultaneous merging of information that matches the selected criteria. So this script has quite a lot more going into it than the search cursor that we demonstrated last. Much of this is to enable an efficient transfer of data. Before I get into the script detail, I'll scroll down to where the insert cursor is placed. The insert cursor is placed here within a search cursor iteration. It's only a couple of lines of code, but it enables the efficient creation of features within a chosen feature class. The aim of the script will be to select the significant categories out of the crime description and place them into a new feature class. So within my scripts, I like to have a lot of commented out sections to give the reader of the script a lot of indication of what is about to occur within any of the code blocks. I'll just quickly show the detail of another script that I have written and like to provide the amount of detail in the forefront of the script so that any member opening these scripts will be able to see the intent or see a bit of background detail to what I'm aiming to achieve. Within the script, we'll only need to import the ArcPy module. No other modules will be required. Scrolling down to the variables. Firstly, we establish the output location. So as I'm just working locally, I'll point this to a folder location within my D drive. I'm providing a name of what I'd like that database to be called. And I'm also providing a name of what I'd like any of my outputs to be called. In some of my scripts, I like to prefix or suffix any of the outputs so they could be quickly identified. And within this variable here, you can quickly concatenate or you combine the provided name with additional text to indicate what part of the output is regarding. Within this variable, I provide the address of the feature class that I wish to use as the input data, acknowledging that this is within a database, providing the geometry type of the input data and what I'm wanting the output data to be. And here, just commented out, I've put the other options. So when I want to turn this into a toolbox, I can place this list as a drop-down selection. And here provide the field name to identify what category. This next variable is a list of categories that I want to select from that database. It's not a traditional Python list. This list may need to be monitored and edited depending on the input data, making sure it's current within the data that you are selecting. case in point, if there's multiple data sources and they use a slight different category for the data that they supply, make sure the category aligns with your analysis, your procedure that you want to be conducting. Scrolling down a bit, I'm listing the spatial reference. For this use, I'm listing the WKID. This is an identifier, and this is currently referencing GDA, or Geospatial Datum of Australia 2020. So this spatial reference will then apply within the environment workspace. We'll discuss this in the environment section. And within my scripts, I like to provide the option to the user whether they want to overwrite and whether they want to create a geospatial database for the output of this script. Both these variables are just a simple true or false statement. In some processes where there's a lot of intermediate data, as in there's data that gets outputted to use for another process, but it's not the final process, I may make a additional geodatabase to hold the intermediate data, and I'll provide the user an option to delete that intermediate data on completion of the script. I make it an option as sometimes seeing the intermediate data can assist some problem solving, some further analysis, or some bug finding. But within massive databases and limited storage, sometimes it's very convenient to delete the data when it's no longer required. This text block here is what I use in most of my scripts. This is relating to that requirement of a geospatial database. Just checks if the user selected true for need a database. It'll check if a database already exists. If the database already exists, then it'll just create a variable and name this output. If that geodatabase does not exist, then we will use ArcGIS management to create a geodatabase in the location of where the user selected and then the name of what the user has selected. Again, it'll create a variable for the address of that geodatabase and finally provide a message of where that storage location is. Where the database already existed or has just been newly created, an environment will be set to say that this new database is now the working environment. Scrolling down a little further, we will create a variable to enable ArcGIS to recognize the spatial reference we've provided, and then ensuring that the environment has been set for that spatial reference. The last environmental setting, being the override function, will be enabled if the user selected true. Override output is set to false by default. So by default, if there's any name clashes, a warning will trigger. Turning override output on will remove that warning and just delete the previously existed clash and create the new output. Scrolling down into the core program section. So within this code block here, we're creating the output feature class. I'm using the ArcGIS management create feature class function, providing the output location, that's the database that's been created, providing the name of what that feature should be. I'm stating what geometry type, this will be point, line, or polygon. For this use, it'll be polygon. And I'm giving it a default schema to utilize. So I'm selecting the input data so that all of the fields will be brought across into the output. I haven't had need to use it yet, but you can put multiple reference feature classes in here. And after this is created, we'll create a variable referencing that output feature class. Next, we'll go in and organize the fields of that feature class. I'll reference the geometry. So this will be how ArcGIS stores and recognizes the geometry of the individual features of the polygon. I'll then create a list of fields for all of the input data. So the actual function is just this part here, arcpy.listFields, and then you, in brackets, put whatever feature you're interested in. But I've wrapped it in this formatting here as just using the ArcGIS list field will provide an ArcGIS readable list. And this formatting just unpacks that. I'm now modifying this list by inserting the geometry heading to the start of this list. This will be used within the insert cursor to create the actual boundaries of individual features. Without using the geometry, the insert cursor might just reference the attribute information, the aspatial information, and not actually create a geospatial feature. Next, we'll get into some setup for the main. Here I'm specifying the SQL Query Expression. Just coming back up to the variables, we're specifying this is the field we'll be looking for, and we're looking for all of the values that are within this list here. So that's where that field reference is there, and that's where the list of fields is referenced here. So what this is Python string formatting. The argument or the expression that is being placed within the SQL needs to be in a string format. And so how do you put dynamic variables, or how do you put things that can be changed within a string? Well, we provide a reference to that string using the percentage sign and the brackets and the S to signify the start, the end of where this variable needs to be inserted. Carry on with the instruction of what the SQL query needs to do. I've had the most problem with these, and so sometimes it might be useful to print what the actual query is, and you might get some insight as to what is occurring when you are calling this expression. At times, these can be difficult to troubleshoot and to find out what formatting they really need to be. So at times it is beneficial to print the SQL query to identify exactly what is being written into one of these formatted strings like this. Within your ArcPro instance, sometimes it can be beneficial conducting a query just to test and see what works, particularly when these can become quite complex, when you're doing multiple checks across multiple fields to identify the specific features and information that you want to return or you want to select. And I'll just quickly highlight here, pretty much this section here and also this section down here, it's all just to provide a message, just to provide a progression message to the user. Depending on how large your data sets are, these may be beneficial to understanding how long a process may take depending on the database. Are you expected to come back to this in 2 minutes, or will this process take 2 days to complete? And so what we're establishing here is a bunch of 0 values. These will be used as counts throughout the next iterations. The next part here, I'll be creating a search cursor to count how many features, viable features, are within my feature class. When I say viable features, it's not just doing a simple get count of the feature class. Because we're enabling this query here, it won't be the total count. So this search cursor utilizing the SQL query is still a very efficient process. As per my previous video, we'll use the input data as the feature that we want to use the search cursor on. We'll specify the fields. In this case, I am listing all of the fields, though it's really probably not important for this process, being that we're just doing a count. Then we're providing the SQL clause here. We establish the for loop to iterate through the search cursor. Then we're just adding 1 for every viable feature within that feature class. And that'll complete that count. Then we're just deleting the search cursor of that count that we've just conducted. And so this feature's now printing the features just to confirm how many total I'm expecting, which will also correspond in the message down here later. Now getting into the main data creation part of this script. Again, we're going to use a search cursor. This will be able to retrieve the data. We'll list through all of the fields, as I do want information from all of the fields of this database. Provide that where clause again, paying attention to what we're calling the search cursor. Again, search cursor 1. Previous search cursor was search cursor count. Shorthand for search cursor 1. Now I've created the iteration through the input feature class. Within this iteration, we'll establish the insert cursor. And what we're specifying here is the output feature class that we're requiring. And we're specifying all fields that we want data to be modified or created in. And this is the same list as the search cursor. So we're doing a 1-to-1. Anything populated within the search cursor will be brought across into the output feature class through this insert cursor. Specifying the name of the insert cursor there. And now, because we're doing no modification, no changing of the information within the input feature class, we will just insert the row of the search cursor as the iteration comes around. So this will create the polygon feature within the output feature class. So just to recap what we're doing here, we're using the search cursor to read each feature of the input database. So the first feature of the input data is picked up. Within this iteration, the search cursor iteration, it's read that information. It's now writing and applying that information to the output feature class using the search cursor row. And then the next feature of the input feature class will be picked up and the same process will be conducted again. So because we don't need the insert cursor anymore, we'll delete the insert cursor. So I've just dedented, the opposite of indented. I've just dedented this delete the insert cursor because I want it to be outside of the iteration of the insert cursor. I want that insert cursor to finish. And before the next part of this iteration occurs, then the insert cursor will be deleted. And then the next iteration of the search cursor will be started. Now just quickly going into the progression messages and counter. Because all the heavy lifting and the hard work is done through this iteration now, we can add 1 to indicate that that's all finished. I like to create a percentage of how much progress has been completed. PERC is the percentage. We'll conduct the formula to create a percentage, so we'll need the total amount of features divided by 100, then times by how much progress has been completed, and then I'm just rounding this to 1 decimal place. And because I don't want a progress count message provided after every feature that's been completed, as some of these feature classes going up into the millions, I just want a progress message for every 5% increment stating that if the percentage, so this calculation here, is above the percentage track, this is the 0 count that we provided earlier, then we'll just make sure that these variables are the same. Because we're rounding to one decimal place here, this can actually be beneficial. If the total amount of features to be processes is in the millions, then 5% might be called a bunch of times, like 4.9% and then 5%, 5%, 5%. So this will only process if the percentage is actually bigger than the previous calculation. And then I'm just conducting another if statement. If the percentage is a full number of 1%, 5%, etc., then this progress message will be displayed. And so that covers off the search cursor now, and we'll then delete that search cursor, which finishes off the script. Before running the script, I'll just say if you have any questions throughout this process, please provide them in the comments. Or if you have similar use cases that you want this to be modified to support, or you want some troubleshooting or problem solving, please put that in the comments as well. All right, now to run. Okay, so what we've printed out here is that where clause. Then what we're printing in this progress is we've got 30 completed of 3,000, and that's 1%. And so on and so forth. Every percent increment that I've listed within this list here will be provided. You could create more or less. All right, that script's now complete. All right, so this is the output here. So here's our data. So we've got, 3001 features of about, I think it was 6,000 total. Threatening behavior, property damage, property and environmental, common assault. And so there's our result of the output. Remember that using an insert cursor can be a very efficient method of creating new output features in a feature class. And there's very different variations and methods to use the insert cursor. Remember to use SQL queries within your search cursor. They can perform much more efficiently. Remember, if you have any questions or want me to provide further detail, please leave a comment. Take care all. Goodbye.